So make sure you have your formula sheet. We're going to be using distance formula, and we're going to be using the back formulas because it's all on 3D shapes. So all of this stuff. Okay. So it says for number 1, biking, Raina is using a coordinate grid to map out how far she has biked from each place in town. If each unit on the grid represents 1 kilometer, Raina traveled blank km round to the nearest kilometer if necessary. So for this, you need to decide, am I finding area or am I finding perimeter? Since it's the distance she's biking around, this is going to be perimeter. Did somebody just knock? Coke?
Oh, crap.
Not crack. Okay. Regular Coke, like soda Coke? No.
Okay. Do you know if like Miss Moore has like extra stores?
No, because I don't think anybody really sells soda.
Because like I know like Miss Baker, she has a bunch of extra in her back closet, but she has a class. I know.
Yeah, no, Moore doesn't have soda. She has coffee and stuff. Yeah, maybe
Might
ask.
have.
Yeah, maybe ask her.
We're kind of filming something.
Okay.
Look,
Yeah. Okay, so for perimeter, we got to add up all the sides. So first we got to find the distance of the sides. So the bottom, we can literally just count. So it's kind of hard to see, but this is your y-axis. This is your x-axis. So if I count the distance of the base, that's 1, 2, 3, 4, 5. So the bottom is 5. Now I need to find the sides. So to find the sides, I'm going to need to use the distance formula. So these sides are different lengths. So first thing I'm going to use is I'm going to use C and A to calculate the distance. So coordinate point C, and remember, it doesn't matter what order you do them in. So I'm going to use C, which is at -4, 0. That's coordinate point 1. I'm going to use A, which is coordinate point 2, 0, 4, which is x2, y2. I'm using the distance formula on my reference sheet, which is all of this. I'll write it at the top of my paper, so that way you have it. If you don't have a reference sheet at home, x2 minus x1 squared plus y2 minus y1 squared. Okay, so this is on your formula sheet. So, and then we're going to use Desmos. So we're going to plug this in. X2 is 0. I am minusing x1, which is -4. So we do have double negatives, but that's okay. I'm bringing down my square, bringing down my plus sign. In the other parentheses, I'm doing y2, which is 4 minus y1, which is 0. If I type this into Desmos, square root, minus -4. Squared plus 4 minus 0 squared. Is that -2? 2. $5.65. So 5.65. So I'm going to do the same thing with the other side of my triangle because they are not the same. So I can't just match it. So I'm going to use yellow to highlight this side. So over here, I'm going to use A and B to find the distance between A and B. So A to B, A is 0.4. B is 2, 0. So same thing, x1, y1, x2, y2. So I'm doing 2 minus 0 squared plus 0 minus 4 squared. I'm gonna type this into Desmos. So I get 4.47. And then if I put that on my picture, 4.47. Perimeter, I add up all the sides. So I'm doing 4.47. I'm adding 5.65. I'm adding the bottom, which is 5. Which is 15.12. So because it says round to the nearest kilometer, if necessary, that means the nearest whole number. So we're just going to say 15. Because 15.12 is like $15.12. So that's going to be closer to $15 than it is $16. 2 says find the surface area of the solid shown. This is a prism. So on our formula sheet, we're looking at prism and we're using surface area because it says surface area. So we're using surface area equals 2 big B plus PH. So we always find big B off to the side. So big B first is just the base, which is length times width. 7 times 3. 7 times 3 is 21. And then we're going to find P. P is the perimeter of the base. So I have 3 plus 3, because there's 2 3s, plus 7 plus 7, because there's 2 7s. So 7 7's 14, 15, 16, 17, 18, 19, 20. So 20. So we're going to plug it in. We have 2 multiplied by big B plus perimeter times height. My height is 4. It's the last number I have not used. So big B is 21, perimeter is 20. So I'm typing this into Desmos. So you should get 122. So the next one says calculate the volume of a pyramid. So if I look at my formula sheet for a pyramid, volume is 1/3 big B H. Big B is the area of the base. So my base is a rectangle. So I'm doing length times width. So I'm doing 12 times 10. 12 times 10 is 120. And then I'm plugging that back in. So I'm doing 1/3 times 120, which is big B. And I'm multiplying by the height. The height in my picture is 10. And then I'm typing this in to Desmos. Oops. Back. Okay. That's nice. So the volume is 400. The next one wants the surface area of the whole shape. Step. So this has 2 shapes inside of it. It is the surface area of a cone and a cylinder. Now, the problem with this is because they're touching right here, they're touching on this inside. You do not have to include that portion because if you're wrapping this like a present, the wrapping paper is not going to touch the inside of the shape. So I'm going to start by writing out the formula for a cone. And I'm going to write the formula for a cylinder. So the normal surface area formula for a cone is capital B plus pi r slant height. The surface area for a cylinder is 2 big B plus PH. Now, the reason why this matters is I do not have to include the base. So we have to cross out the lateral height or cross out we're just finding the lateral height of the cone. So we are not using big B for the cone because I do not need the base because the base is touching. Now the cylinder also, you have to think that's just sharing this top piece. So I only need one base. I don't need the top because my wrapping paper is not going to touch the inside. So I do not need 2 Bs. I need technically 1 B. So I can cross out my 2. So for my cone, if I'm looking at my cone is here. All I need to plug in is my slant height, which is 22. And then I need to plug in my radius, which is the same as the bottom, which is 7. So we're doing pi times 7 times 22 for my cone. And it says round to the nearest tenth, so we're doing 483 point, I think that says 0.5. 0.5. No, it says 0.8. For my cylinder, big B is the area of the base. So I'm going to do that off to the side. So big B is the area of the base, which is a circle, pi r squared. So it's a circle. So I'm doing pi times 7 to the power of 2. Which is 153 point, we're rounding to the nearest tenth, so I'm going to leave it as 0.9 because this is what I get. So it's 93, so I'm going to leave it as 0.9. So 153.9, bring down my plus sign. I also have to find perimeter off to the side. Perimeter for a circle is circumference. So I'm actually using circumference equals 2 pi r. So we're doing 2 times pi times my radius, which is 7. So 2 times pi times 7 is 43 point, this is 98. So the 8's going to round the 9 up, which is actually going to round up to the 3. So that's actually 44 because we're rounding to the nearest 10th. So I'm going to plug it in, 44, and I have to multiply by the height, which is 15. So after I multiply these and add them together, so this is 660, add 153.9. $813.9. Then the last thing I need to do is actually add these two together. So I'm adding them. So plus 483.8. So I get 1,297.7. The next problem says, what is the volume of the solid to the nearest tenth? So the next problem is a cone. So I'm using volume of a cone. Cone is 1/3 big B H. Big B off to the side, we're going to do pi r squared because the base is a circle. So we're doing pi. And then because they give me the whole distance is 10, I'm not using 10, I'm using 5 for the radius. So 5 squared times pi. Five to the power of 2. Is 78 point, and it says 10, we're running to the nearest tenth, so 5. I'm gonna plug that in, 78.5 times the height. Now they give us two heights. We're using regular H, so just 12. So you get around, oh, times 12 and then times 1/3. That's what we're supposed to do. Times 1/3. Let's put it in at decimals. Here. 1/3. I'm 78. Times 12. $314. The next one says the volume of a beach ball has a volume of 523. Kayla wants a ball with double the volume, so we're gonna double this. And then you gotta figure out which diameter would work. So we're gonna take 523. We're gonna multiply by 2 because it's doubling. Is 1046. Now I need to figure out which diameter is going to make this amount. So this is diameter, so we're going to cut it in half like we did in class. 6.3 divided by 2 is 3.15. Divided by 2 is 2.5. Divided by 2 is 6.3. Divided by 2 is 5. So we need to figure out which diameter is going to work for this. So the volume formula we're using for a beach ball for a sphere is 4/3 pi r cubed. So I have to plug it into Desmos and see which one comes out to be the closest. So 4/3 times pi times, we'll do the first one, 3.15 cubed. So that's 130. That's not close. So let's change our number. 2.5. 2.5. That's not close. 0.3. 1047. Oh, that one's really close. Okay, so it's probably this one. I'm gonna try the last one just in case. So it's probably C. C. Last one that I need to try is 5. Yeah, so C is the answer. 7 says the shape of a water tower is partially modeled by a sphere, and the diameter is 28 feet. A painter needs to calculate the surface area of the part of the tower that to accurately estimate the amount of paint he needs for the job. What is the surface area of the portion of the tower to the nearest square foot? So we have a sphere. So don't let all the words confuse you. You have a sphere. They're saying the diameter across is 28. We need surface area. So we're going to use surface area formula for a sphere, which is 4 pi r squared. Now, if my diameter is 28, that means the radius is half of it. So we're going to do 4 pi 14 squared. Four times pi times 14 squared. So 2,000. And it says to the nearest foot. So we're not rounding, we're rounding to the nearest whole number. So 2,000 or 63. On the back, it says we are rotating a two-dimensional figure around a line. What figure would best result in the rotation? So a lot of people are choosing C because they're like, it's going to spin around and it's going to match on the other side, which is true. It is going to match on the other side, but you have to think that there's technically a gap in the middle because it's not actually touching this line. There's going to be an empty circle, like a donut in the middle. So it is not C because there is a gap. It's actually D because that has the gap in the center. Number 9 says part of Marcia's duties as a police officer is required to patrol the triangular area between the museum, the bus stop, and the city hall, as shown in the coordinate grid. Determine the area in square feet that covers her patrol. So for her patrol, we are going to find area because we want to know the area that she covers. So area for a triangle, because this is a triangle, is 1/2 base times height. So if I look at my base, I can just count across. We're going from 0 to 4. 1, 2, 3, 4. The height of my triangle, not all the way to the x-axis, to C to A, is 1, 2, 3, 4, 5, 6, 7, 8, is 8. So we're doing 1/2 times 4 times 8, or 4 times 8 cut in half. Which is 16. For number 10, it says select all the figures that have a triangular cross section when sliced perpendicular to the base. So you're looking for a triangle cross section. So whenever I slice it perpendicular to the base, meaning vertically, fruit slice it vertically. And also this problem might continue over here. We're looking for a triangle. So if I slice this, that would not make a triangle vertically. It would make a triangle horizontally. It has to be perpendicular to the base. So that is not true. This one, if I slice it, would make a triangle on the inside because it's a 3-dimensional cone. So the inside would make a triangle. This one, the inside vertically would make a rectangle. This one would make a square. So this is one of them. Because I'm looking for triangles. This one, if I slice it, would also make a triangle. And this one would also make a triangle. Anything that basically comes to a point at the top is going to make a triangle because it's wide at the bottom and then it's skinny at the top. Wide at the bottom, skinny at the top. Wide at the bottom, skinny at the top. So all 3 of these will make triangles when sliced perpendicular to the base.